Hey guys, in the previous chapter we learned about the binomial distribution, and we learned that when there's a particular situation which has characteristics, that situation can be mapped onto the binomial distribution. Well, the same goes for geometric distribution. The geometric distribution is also a discrete probability distribution, and we can map a situation onto this distribution based on particular characteristics. Now, binomial distribution and geometric distributions have the same characteristics apart from a few. One of the first characteristics we learned was that the outcomes of interest are perceived as success, and the outcomes that are not of our interest are perceived as failure. So the same goes for a geometric distribution, that we have outcomes which are considered as success and outcomes that are considered as failure. So we have two sorts of outcomes. Another characteristic which is the same of a binomial distribution is that the trials are independent. The trials are going to be independent. And also one last characteristic which is the same is that the probability of success and the probability of failure is constant from trial to trial. So there are independent events, independent trials, and the probability of success and failure are both the same from trial to trial. Now comes the part which is what is the main difference between a binomial distribution and a geometric distribution. A binomial distribution has a finite number of trials, and we are interested in seeing how many times do we succeed in a certain number of trials. Do we succeed 5 times? Do we succeed 6 times? Do we not succeed at all? And when we do not succeed at all, that means that our random variable is equal to 0. So this is what a binomial distribution does. It tells us the number of successes in a certain number of trials. Now for a geometric distribution, we do not have a finite number of trials because a geometric distribution tells us when we are going to succeed for the very first time. For example, we are rolling a dice and we succeed when we land on a 6. So how many times do we need to roll the dice before we land on a 6 for the very first time? Does it take 5 trials? Does it take 6 trials? Does it take 1 trial? So a geometric distribution does not have a finite number of trials. We do not know how many trials it will take for us to succeed for the very first time. So in this example where we are rolling a dice and our probability of success is when we land on a 6. So the probability is equal to 1 upon 6, and our probability of failure is not landing on a 6, which means 5 upon 6. And we want to know the probability of us landing on a 6 on the 5th trial. So that means that our random variable capital X equals to 5. So in this case, now we do not need to list down a number of different arrangements, a different number of possibilities. In this case, we simply know that we are landing on a 6 in the 5th trial. That means the first 4 trials we are failing. So doesn't that mean that we are failing in the first trial, we are failing in the second trial, we are failing in the third trial, we are failing in the 4th trial, but we are succeeding in the 5th trial. So that means there are 5 failures. So we raise 5 upon 6 to the power of 5. And then we have 1 success right at the end, which is the probability of success. So this will give your answer to the probability of getting a 6 in the 5th trial, or the probability of succeeding in the 5th trial. This is what our geometric distribution tells us. However, it is important to note over here that there is no probability of x equals to 0. So the probability of finding x equals to 0 does not exist in a geometric distribution. And why is that? Because this number represents the number of trials it takes for us to succeed. But if there are 0 trials, how are we going to succeed for the very first time? So the minimum number of trials that we need for a geometric distribution is 1. So I'm just going to put this pointer here that x cannot take the value of 0. It cannot take the value of 0, but also at the same time, there is no upper limit to the number of trials. So the minimum number of trials is 1, but the maximum number, there is no maximum number of trials.